Last but not least, Chapter 17, naming of aldehydes and ketones. Let's start with aldehydes. We're going to replace the E of the parent chain, the parent alkane, like hexane, with al, Al. So, hexanal. And the carbonyl carbon always gets position number 1 when we move to more complex molecules. So the first example, we have 1 carbon. So the parent alkane would be methane. Okay. We drop the E of methane and change it with Al, so methanal. Okay. Methanal. You need to know the common name of this guy. You might already know it. So the common acid would be formic acid. This is formaldehyde. Okay. Formaldehyde is the common name. And then the next one, there's 2 carbons. So ethane is the parent alkane. Drop the E, replace with Al, and you'll get ethanol. Now the common name here, probably one that you want to know. The common acid, so if this was OH, would be acetic acid. So this is acid aldehyde. Acid aldehyde is the common name. Look at a few more. For example, let's name this aldehyde. So remember that my carbonyl carbon gets number 1. So there's 2, there's 3, there's 4. So butanal, okay, will be the name of the aldehyde, but we have to include the substituent at the 3 position. So it's 3-chloro butanal. 3-chloro butanal. Okay, you're going to name all of them like that. Now I want to show you just a couple of, what's the word? I'm drawing a blank. Exceptions. There we go. A couple of exceptions, or a little different, if you remember, with rings, or if we have 2 aldehydes on 1 compound. So for example, let's name this. Name that guy. So there's 2 aldehydes on this compound. We can number either way: 1, 2, 3, 4, 5. So instead of Al, it's going to be dial, and there's 5. Okay. So we can go ahead and keep the E, pentane dial. Pentane dial. The reason why we can keep the E is because there's a D there instead of a vowel, so we don't have to drop it. Let's look at another example. So now the aldehyde, carbonyl carbon of the aldehyde, is directly attached to the cyclohexane ring. So it's very similar to a carboxylic acid. So instead of saying cyclohexane carboxylic acid, we're going to say cyclohexane carbaldehyde. Cyclohexane carbaldehyde. So we actually keep the whole carbaldehyde there. Alright, let's do another one like that. Instead of cyclohexane, we got benzene. So the name of the ring is benzene. Okay. And then we just add the carbaldehyde. Benzene carbaldehyde. Okay, one word. The common name for this is just benzaldehyde. So if you hear somebody say benzaldehyde, that's the common name for benzene carbaldehyde. All right. Now let's go to ketones. Some ketones. So we're going to, once again, to name a ketone, you replace the E of the alkane here with one, O-N-E. Replace E with O-N-E or one. You number the chain, so the carbonyl carbon gets lowest number. So we number in such a way that our carbonyl carbon gets the lowest number it can in the chain, in the longest chain. And then in cyclic ketones, the carbonyl carbon is always number 1. So carbonyl carbon number 1 in cycles. If it's number 1, we don't have to specify it. If it's always number 1, we don't have to put it in our numbering. All right. So let's look at an example. Let's look at this example. So here we're going to replace the E. There's 3 carbons, 1, 2, 3. The only carbon of these 3 where we can have a ketone is the middle one, so we don't have to put a 2 there. Okay, and instead of propane, it's propanone. If we put the carbonyl, if we put the double bond to the oxygen here, it would be an aldehyde, not a ketone. So we don't have to put 2 for propanone. Look at another one. Wait, I need to go back right there. There's another way of naming these called the derived method, where you just simply say what's here and what's here, and then you say ketone. So this is a methyl ketone, but there's 2 of them. So we could also call it, so it was the IUPAC naming was propanone. The derived naming would be dimethyl ketone. And then what you're going to hear everyone in lab call this is the common name of acetone. That's acetone. We use it to wash our glassware. Okay? Let's name this compound. So the longest chain that's got the ketone is 1, 2, 3, 4, 5, 6, 7, 8. Octane would be the parent hydrocarbon. So it'd be octanone. And now we got a number. We can either number starting here with 1 or starting here with 1. Starting from the left, the carbonyl carbon gets the lowest number it can, 3. So it would be 3 octanol. 3 octanol. What would be the derived method, the derived name of this? So I've got 1, 2, 3, 4, 5. So that as a substituent would be pentyl. Or I've got 1, 2 here. That would be ethyl. So ethyl, E comes before 3, comes before P. So we could say ethyl pentyl ketone. Ethyl pentyl ketone. do another one now. Let's do a ring. Okay. So this is a ring. So we don't have to specify number one. The carbonyl carbon is always going to be number one in the cycle or in the ring. So this is just cyclopentanone. Cyclopentanone. And then the last one for the ketones, before we put them together, let's look at a compound that has two ketones, a diketone. So instead of on, O-N-E, when we replace the E, now we're just going to put dione. Okay, dione. So we can say 1, 2, 3, 4, 5. So it's pentane dione. So it's 2. So the carbonyl carbon's at 2 and at 4. 2, 4. We have to specify that because it could be a 3 or it could be a 1 and 3 or however we number. So it's 2, 4. Pentane dione. Notice that we kept the E on there because it's not next to another vowel. So it's 2, 4 pentane dione. All right. Our naming can get a little bit complicated when we've got so many functional groups that we're talking about now with their reactions and things like that. So we can have a ketone and an aldehyde on the same compound. And we can have an alcohol and an aldehyde on the same compound. Things like that. So let's look at naming with multiple functional groups. And this is the last part. Naming with multiple functional groups. And you need to see table 17.1. It lists the functional groups in order of priority. So the highest priority to the lowest. Okay. You need to take a look at it. I'll try and remember to post it to Blackboard. You won't hurt my feelings if you help me remember to do that. Alright. And what we're going to do is if we have two functional groups, the high priority one, okay, the high priority we'll use as a suffix in naming. Okay. The low priority we'll use its prefix name. So for example, if the alcohol was the high priority functional group, it would be the suffix like hexane-1-all. But if it's a low priority, it would be a prefix, so we would say hydroxy, and it would be out in front as a prefix. So here's an example. So right now you don't know it well enough to know that a ketone gets priority over the alcohol, but table 17.1 will help you until you realize that. So we would number to where our ketone, our carbonyl carbon, gets the lowest number it can. 1, 2, 3 versus 1, 2, 3, 4, 5. So we start from the right. 1, 2, 3, 4, 5, 6, and 7. Our high priority is the ketone. Okay. Our low priority is the alcohol. So it's going to be 3-heptanone and then we add the alcohol as a suffix. So it's 6-hydroxy, 6-hydroxy 3-heptanol. 6-hydroxy 3-heptanol. So the high priority ketone is a prefix. The low priority alcohol is a substituent, a suffix. Let's do another one. We have an amide and an aldehyde. We got to determine which one gets priority. Okay, and I'll tell you now that it's an amide. So amide is greater than an aldehyde. Okay, so our amide will be treated as a suffix, the aldehyde as a prefix. So this is going to be treated as a prefix, and we'll call it formal. This is a formal group. Remember formic acid or formaldehyde? So this is a formal substituent or a formal prefix, excuse me. So now we're going to number where our highest priority gets as low as it can. So that's 1, 2, 3, 4, 5, and 6. Okay. So hexanamide, okay, is the parent chain, and then we got to include the formal group at the 4 position. So it's 4 formal hexanamide. Yeah. All right. Let's do one with an alkene now. Let's do one with an alkene. Alkene and a ketone. Ketone's going to get higher priority over an alkene. Okay? So ketone greater than alkene. Okay, but an alkene special because it's right along in the chain, so we can use it as a suffix as well. So both the ketone and the alkene will be treated as suffixes here. Okay, so but still use suffix for both. Okay, and you're going to put the alkene out in front of the ketone. So let's number now. So our high priority group, the ketone, gets the lowest number it can. So that'll be from the left. 1, 2, 3, 4, 5, 6, and 7. Okay. So it would be 3-heptanone, but we have the alkene. Okay. So how are we going to name it? Take a second and see if you can figure it out. What position does our alkene start at? It's at 1, right? So we have to indicate that. So 1 heptene, going to drop the E. Going to drop the E because on is going to be next, another vowel. 3 on. So 1 heptene, 3 on. I want to give you one more. I doubt there'd be a whole lot of these on there because you've got so much material to be tested on. But just in case, let's do one that looks hard. So we have a ketone and an nitrile. Check table 17.1, see which gets higher priority. Believe it or not, it's a nitrile. Okay? So the nitrile will be our suffix, the ketone will be treated as the prefix. Okay? If we didn't have the ketone and I asked you to name this, you would say cyclohexane nitrile, right? You're going to do the same thing, but just indicate that we have the ketone there as well. So it's going to be 2. So this is position number 1 because our high priority group is attached at that position. This is going to be carbon number 2. We have to indicate that it's a ketone prefix, and you do that 2-oxo. Okay. Oxo lets us know there's a ketone there at the 2 carbon. And then we just write it as if it wasn't there. Cyclohexane nitrile. 2-oxo cyclohexane nitrile.